Now today I'm going to solve a question on application of derivative. The question is find the minimum value of the e expression which is equal to x1 minus x2 whole square plus x1 square by 20 minus root over this whole square, where it is given that x1 belongs to real positive and x2 belongs to the range 13 to 17. Now there are two ways to solve this to find the minimum value. That is, first I'm going to differentiate this and find a relationship between x1 and x2. Then I'm going to equate it to 0 f dash of x. Then from there, I'm going to find the maximum minimum. And second is the most beautiful way here is graphical approach. So I'm going to rewrite this E as here as x1 minus x2 whole square plus, let's say for a moment this value is equal to y1 here. And this value is equal to here y2. From my side I'm taking here. So I'm writing this as y1 minus y2 whole square here. Now next step is here I've taken y1 as I've taken as x1 square by 20, and here I've taken y2 as you can say y2 square because root over will be removed, and that is equal to 17 minus x2 and then x2 minus 13 here. Now I'm going to rewrite this as on the other side it will become you can say x2 minus 13 and then x2 minus 17 here, and then plus y2 square I can write, and the negative I've consumed here to make this x2 minus 17 here. Now the first one I can see it's a parabola, as you can see, and the second one is a diametrical form of circle is written here. I'll write this is a parabola passing through origin, and this is a equation of a circle is written in diametrical form. Now if the moment you take the root over here, it all makes sense because the moment I take root over here, it gives me a distance formula. So it gives me an idea that they are asking the distance between 2 points, and they are asking minimum distance between 2 points. The points are x1 comma y1, and the next point is x2 comma y2. Now x1 comma y1 is lying on the parabola and x2 comma y2 is lying on the circle. Actually it's a semicircle because if y2 is under the root over, that means y2 is positive. If y2 is positive, that means it represents a semicircle. So they are asking us to find the minimum distance between parabola and circle, and they're not asking the distance, they are asking the square of the distance because root over e is the distance and square of e is e. So let's calculate. Now I have to find the minimum distance between this parabola and this semicircle. So now this parabola is passing through 0, 0. As you can see, we have to select one point on this parabola. Let's say P is the point, x1, y1. And Q is the point on the semicircle. Let's say x2, y2. We have to select in such a way that minimum distance exists. If there is a minimum distance between these 2 points, then that means the value of E will be minimum. And if the value of E will be minimum, that's our objective here. So let me show you through diagram here. So this is the parabola which is passing through origin, you can see 0, 0 here. And I have to draw a semicircle whose diametrical endpoints are 13, 0 and 17, 0. As you can see, both points are lying on x-axis. The semicircle will be like this. Let's say A is a point here which is equal to 13, 0, and B is one point here which is 17, 0. And center of the circle will be somewhere here, C. That is, you can say here C, 15, 0. Now we have to find a point P on the parabola, that is x1, y1, and we have to find a point Q which is x2, y2. So I'm going to tell you a new concept here. This is really good concept and important for JEE. That is, if you want to find the minimum distance between two curves, you have to draw a tangent here and one more tangent on Q in such a way that the slopes of these two should be same. That means these two tangents should be parallel. If these two tangents are parallel along a common normal here, you will get the minimum distance here. Now this is our common normal here. Now if the common normal is there, because it is 90 degree and 90 degree here, you will get the minimum distance between two curves. So remember, when you want to find the minimum distance between or the shortest distance between two curves, it will be along the common normal. Now my objective here is to calculate x1 y1 point and x2 y2 point in order to calculate the minimum distance. So let's write the equation of normal. For equation of normal, I need the slope of normal. So let's say slope of normal is m of n and slope of tangent on the parabola is m of t. So let's calculate m of t first. That means I'm going to differentiate the parabola, that is 2x1 by 10. And if I calculate this, this is x1 by, sorry, x1 by 20, and this will be x1 by 10 here. So from here, slope of normal will be negative reciprocal of this, that is minus 10 upon x1. Now, through equation using this and using the point x1, y1, I can calculate the equation of normal here. So equation of normal is y minus y1 is equal to minus 10 upon x1 here, and multiplied by x minus, you can say x1 here. Now, if it is a normal to circle, that means it's going to pass through the center of the circle. So this normal passes through 15, 0 here. So let's satisfy 15, 0 here. We'll get this as 0 minus y1. And instead of y1, I'm going to write this as x1 square by 20. And that will be equal to minus 10 by x1 here. And then the point is 15 minus x1 here. Let's cross multiply. So first of all, negative and negative will cancel out. We'll get this as x1 cube is equal to 20 into 10, that is 200, and then 200 multiplied by 15 is 3000 here. Minus, we'll get this as 20 or 200 x1 here. Now I'm going to rearrange this cubic as x1 cube plus 200 x1 minus 3000 here is equal to 0. Now one of the trivial roots of this cubic I can see here is 10, because 10 will satisfy here, that is 1000 plus 2000 minus 3000 will be equal to 0. So I can see one of the factors of this cubic is 10. Now let's find the quadratic, because there will be 3 roots. So x1 square is there, because if I multiply x1 with x1 square, it will give me x1 cube. Now we want the constant value to be minus 3000. So constant value will be plus 300 here in the quadratic, otherwise we'll not get minus 3000. Now next we have to think is how should we get 200 x1. So I think if you take here 10 x1 and multiply and check, I think you will get this as 200 x1. So this is satisfying here. Now one of the trivial root is 10. Let's find the root of this equation. So here this is a greater than 0, and if you calculate the discriminant, I think you will get this as less than 0. That means d less than 0 means no real roots. That means only one solution exists here, and that is x1 is equal to 10 here. So if x1 is equal to 10, let's calculate y1. So y1 is from this given relation, y1 is, I think x1 square, that is 100 upon 20. I think it is equal to 5. And as you can see, the p point we got, that is x1 comma y1, that is 10 comma 5. And it's visible here also. The p point will be, x coordinate of p point is 10 and the comma 5, because it is less than 13 on the left hand side. Now we don't have to calculate x2 y2. Without even calculating x2 y2, we can calculate the minimum distance. Now our objective is to calculate the minimum distance between these two curves, that is pq. Now as I told you, I don't need q point here. So because I'm going to write pq as here, I can write this as pc, the distance of p from center, minus the radius. Now radius of the circle is easily can be determined. The radius of the circle is 2. As you can see, distance from center to the circle is 2. Now pq will be equal to pc. We can easily calculate the distance between this point p, that is 10 comma 5 from 15 comma 0. I think it is root over 25 plus 25 here, clearly visible. So that is root over 50. That is, I can write this as root over 5 root 2 here, and minus radius is 2. So that is the pq distance, and that is the minimum. Now e is equal to the square of the minimum distance, that is the minimum square. So that will be equal to 5 root 2 minus 2 whole square. So this will be our answer, and that'll be all.